Hello again, 8th grade. This video is going to be all about acids and bases. So we've been learning about mixtures and solutions and all this stuff, but why does it really matter? Why is this a topic that we pulled out of things to give you to learn about? Well, the reason is because solutions cause some really weird things to happen. Water is a really weird solvent that things can go into. Some people think it's the best solvent in the world, and it's the most common solvent in the entire world. One of the things that happens when you have a solution with water is that it can break apart substances. For example, I have right here a box of baking soda. Baking soda, if you look at the chemical formula for it, is sodium hydroxide, which is a sodium atom bonded with an oxygen and a hydrogen. So if you remember back to what we learned last chapter, sodium is a metal and oxygen and hydrogens are both non-metals, even though hydrogen is part of the alkali metals. Both of those are non-metals, which means that the bond is going to be an ionic bond. An ionic bond, when you put it in water, will actually break apart. So I've got some water here. So we've got some water. If you put the baking soda into the water, and I'm pouring it out of the wrong side. If you put the baking soda into the water, and stir it around a bit. Okay, so what's happening here in this cup of water with the baking soda is that the sodium and the hydroxide ions are breaking apart. So while it's in the water, the sodium and the oxygen and hydrogen are not bonded together anymore. They're apart and they're just in the water separately. This allows stuff to react with the substance much faster than it would with just this powder form of the substance. Also, another thing that's interesting is sodium hydroxide, or baking soda, is what's known as a base. A base is kind of the opposite of an acid. You probably remember with acids tend to rust things or dissolve things away, and they can be harmful for your skin depending on what they're like. So I've got some really weak acid here. It's called vinegar. You've probably heard of it before. And we're gonna add some of this to a different thing over here. So you guys have seen this reaction happen a lot of times before. I've probably seen this dozens of times, but we haven't really talked about it in this context. Sodium hydroxide is a base, and the reason it is a base is because when you put it in water, it creates OH ions, which are called hydroxide ions. So OH ions are what bases produce when you put them in water. There's lots of kinds of bases out there. I think there's potassium hydroxide, lithium hydroxide, there's all kinds of bases. But they all dump that hydrogen, they all dump that hydroxide ion into the water when you dissolve them in water. On the other hand, acids also have a similar property. They release hydrogen ions, so H ions, all by themselves. H ions, since a hydrogen only has one proton and one electron, when it's an ion, that means that the electron has been removed. So all you're really left with is one proton by itself. Acids are known for releasing single protons into water when you mix them with water. So this is a solution of acetic acid, which is what vinegar is made out of, and water mixed together. And it's not super concentrated. Remember, we learned that concentration is how much of the stuff is actually in the water. There's not a ton of acetic acid in here, but it is enough for us to see the reaction. When an acid is mixed with water and it releases those single protons or hydrogen ions, and it is mixed with a base which has released OH ions into the water, a chemical reaction always occurs. This is the other kind of special case reaction, and really it's a double displacement reaction if you think about it. Because what's going to happen is the sodium from here is going to react with the other compound from acetic acid, and the H that's been released by the acid is going to react with the OH that's been released by the base in this reaction that's going to be shown down here. You can see when an H and an OH react, they always come together in a synthesis to form water. So no matter what acid you have reacting with what base, you always get a water and a salt out of it. If we were going to react hydrochloric acid with this sodium hydroxide, since it's hydrochloric with the chlorine and it's sodium, the sodium would react with the chlorine, and that would actually form normal table salt because it's the sodium and the chlorine. So you would end up with table salt and water, which are both really normal substances. So scientists will often use bases like this to neutralize strong acids they may have left laying around their lab. They'll just spread this over the floor and it'll neutralize or pick up any of those hydrogen ions that have been left around, because they can be really dangerous. One of the reasons why the sulfuric acid that we used in class was so strong is that its chemical formula is H2SO4. It releases twice as many hydrogens as hydrochloric acid. Okay, so let's put these together. Oh my gosh, and you've seen this happen so many times. This reaction is great. This reaction releases a lot of bubbling, a lot of fizzing, a lot of splash. And if I do it again, it still happens. But what's happening here is a lot of these acid molecules have been neutralized, which is why it's now not foaming as much. There is not nearly as much acid left in there as there was. So that is one reason why solutions are so important, is because when you dissolve chemicals in water, it can break them apart so that each ion is floating around, and that can lead to some interesting stuff. Another thing that you might want to know about is the pH scale. So we ran into that before in science class, where you need to measure the pH of something. pH is a scale that measures how acidic something is. So if something it's a scale that goes from 1 up to 14. So if something is really acidic, if it has a lot of acid, it might be closer to 1. 1 means you're really acidic. Whereas if you're really basic, you'll be way up at the 14. But what does that actually mean? Why is it 1 to 14? What's the deal with this? Why is 7 considered neutral? So it has to do with the concentration of hydrogen ions. So pH, the H actually stands for hydrogen ions, which are always released by acids. So if you only have a little bit of them, you will have a higher score. If you have a lot of hydrogen ions, you'll have a lower score, which means you're more acidic. There's actually a scale that is the opposite of the pH scale called the pOH scale, and that measures how many hydroxide ions are in the solution, which will always come out of bases. So it's like a base scale instead of an acid scale. But we normally always use the pH scale to measure stuff. So the things to remember are acids neutralize bases. They always produce water and some type of a salt when they react and neutralize each other. Acids release hydrogen ions when they're dissolved in water, and bases release hydroxide ions when they're in water. And pH is a scale that measures how many hydrogen ions are in a solution, and that determines the amount of acidity that you'll find in the solution. So go ahead and fill out the notes below, and then you can work on the worksheet that goes with this. I'll see you later.